In this video, we're going to continue our study of the substitution approach for evaluating integrals. Take a look to start with at the integral here, and ask yourself which of these possible substitutions would be most effective at simplifying or tidying up this integral, making it an integral that's easier to evaluate. Take a moment to think about it, and then we'll check in. All right, looking at this, what catches my eye is the sine of x as a multiplier. That points to cos of x being a useful inside function, because we know when we do a substitution, this will lead to dividing by the derivative of cos, which is minus sine of x. And if we divide by sine of x, well, it'll get rid of that sine of x on top. So this to me seems like the most plausible candidate for our substitution. There's one in second place for me, the whole denominator, but we know that that would lead to dividing by, well, the derivative of cos squared. I have to be a little bit careful. It's like all of cos all squared. It would be dividing by 2 cos of x times sine of x. I'm not sure that would simplify this expression if that's what the substitution did for us. So I would lean towards this first, see if it works. If it doesn't, maybe fall back to this other substitution, but definitely try the simpler option to begin with. And so that's what we're going to try first. We're going to pick our w as cos of x. Once we've made that decision, then we just follow the process for a substitution integral. We find the derivative, that's negative sine of x, and then we isolate the dx part. That gives us 1 over, or negative 1 over sine of x. dw stays there. Then the dx comes up, and we get that expression. Then we try to rewrite our integral. And when we rewrite the integral, I find it helpful sometimes just to call the whole integral that we started with I. It means we don't have to recopy it down lower if that has been done. So our integral is this. We can replace what? Well, we pick w to be cos, so the sine will have to stay around. In the denominator, we had 1 plus cos squared. If w is cos, that'll be w squared then in the denominator. Then we had the dx term, which we just said could be replaced by negative 1 over sine of x. And there's the dividing by sine of x that we want to do because it lets us cancel. And when we tidy that up, we end up with the integral of 1 over w squared, 1 over 1 plus w squared dw. We do our little check. This is definitely simpler, and it has no x's anymore. Perfect. The question is, do you remember what you can differentiate? What do you have to differentiate with respect to w to get 1 over 1 plus w squared? Think about it for a moment. If you don't have it handy, look back in your tables. But the answer is arctan. If we take a look at the arctan of w, the derivative of arctan is 1 over 1 plus w squared. Then we include the plus c at the end, and we're basically done. We just need to go back to x's, because that was the form of our original equation, our original integral. So our w was equal to cos, and that would become our antiderivative of that quite reasonably complicated expression up top. Another successful implementation of the substitution method.